Hi guys, can you guys hear me?
Yes.
Okay. Alright, so here's a brief announcement regarding final exam review and final exam time. By end of tonight, I will try to upload the final exam topic sheet, which lists topics that are going to be covered in the final exam. I will also narrow down the sample exercises that you have to focus on. And on Thursday, what we're going to do is we will quickly go over this final exam topic sheet together and discuss how to effectively prepare for the final exam. And if anyone wants me to go over any specific sample exercises again during this review session, I will go over those sample exercises again with you. Okay? So, and on Thursday, I will tell you approximately how many questions will be on the exam, what information will be provided during the exam, and what needs to be memorized. Okay, I will go over the details of a final exam on Thursday. Okay, I will try to keep everything as straightforward as possible. And originally I did not want to re, reveal the exams. I did not want to show you the exams, but um, I've been I've been reading a lot of feedbacks from you guys from exam three, and a lot of the students were having issues with managing having issues with pacing. Okay, they were having issues with the time. Okay, time they have to um, spend for each questions. Okay, so I have opened up the exam 1, 2, 3 for you guys to see. Although you need to have the lockdown browser, and that was intentional. Okay, I don't want the exam to be um, revealed to outside. So only use this exam to test your to control the pace of the exam. Okay, so I will study first. I will do the sample exercises again first. I will review I will study the chapter 24. I will review all of the previous exam materials first, study first, and then I would use the exams to um, try to do the actual practice exam. Okay, and actually time myself. Okay, that's how I would use it. But if you want to log in multiple times to use it, that's totally fine. Okay, but try not to screenshot or take picture of the exam, because I don't want the exams to be leaked outside. Okay, so that's that. So exam 1, 2, 3 are available for you guys to see. Another thing is that I made a mistake in exam 3. I input incorrect answer into the software. So question 9 correct answer should supposed to be D. Okay, so anyone who chose D that were marked incorrect in the beginning, I gave additional 3.25 points. Anyone who chose B and got it correct, B was an incorrect answer. So anyone who chose B was marked off 3.25 points. Okay, so that's that. For the final exam time, everyone must take the final exam on next Tuesday, May 10th, from 1 p.m. to 3 p.m. Most of the students should not have any conflict with other final exams because exam time is for classes on Tuesday 1 p.m. But in rare cases, if you have conflict with other, if you have conflict, or if you have more than 3 final exams on the same day, you can request a different time to take the exam, but you have to show me the proof that you have conflict in final exam schedule, or you have to show me the proof that you're taking more than 3 final exams on that same day. So, screenshot of your final exam schedule announcement, screenshot of syllabus, any type of proof will be accepted. If you are experiencing medical emergency, please send me the doctor's note to reschedule the exam. Any personal issues cannot be brought up to adjust the final exam schedule, such as forgot to take the exam, family member came over so the house is loud, computer is not working, or work schedule, etc. Those will not be for those issues, I cannot grant the I cannot adjust the final exam time with you guys. So, and another thing is that really need to finalize the grade during next week. So I have to report the grades to the department, chemistry department. I have to upload the grades onto my UNLV. So I will be extra occupied from the day after the exam. So there will be no makeup exams available no matter what. So if your internet fails during the exam, if your lockdown browser fails during the exam, and if you can't resolve it right away, your score will be as it is. Okay? So if you are having back-to-back final exam, then try to reschedule your final exam. Okay? Because in case you encounter lockdown browser issue, you have to close out the exam immediately, send me an email, call OIT, resolve the issue immediately, and then continue the exam. Okay? If you just log out of the exam, and if you have if you have to go somewhere because you have another final exam, if you have another class, for example, and you try to take it again that afternoon or the other day, that's not going to happen. Okay, I don't have time to prepare another exam for you for the final exam. So if you can resolve the issue right away, that at that moment, I can extend the time for you. I can extend 15 minutes, 30 minutes, or even 1 hour for you. But if you stop the exam in the middle, and if you try to take it again sometime later that afternoon or the next day, that's totally not fair. Okay, so in that case, your score will be as it is. So please make sure, double check, triple check your internet connection at home. Make sure you have stable internet connection. And if you have previously experienced issues with lockdown browser, please contact OIT ahead. Resolve this issue before you start the exam. If you are so afraid that you're going to experience trouble with the internet, you can also schedule an in-person final exam with me. I will head over to the department and proctor your exam in person. Okay? And the final total grade calculation Excel spreadsheet is uploaded on Web Campus, so please make sure, feel free to use this to calculate your own total grade ahead of time if you're interested. Okay. Again, you don't have to email me anything about your grade. I will do both calculations, and I will choose whatever gives you higher percentage. Again, you can do your own calculation, and if you see any discrepancy between your calculation and my calculation, let me know immediately. Any questions about final exam?
Yes, Dr. Lee, I have two questions.
Mm-hmm.
When you said to do the sample exercises, you're referring to the ones you're going to give us to solve like later on today that you said you were going to post?
Sample exercises, the one that you've been.
Or you mean the whole sample exercises from all the chapters?
Yeah, but I will narrow down which sample exercises that you have to focus on.
Okay, thank you. And then one more thing, for the final exam, you said from 1 to 3, so it's going to be 120 minutes, or is it going to be 75 minutes as usual?
Final exam is 2 hours.
Okay, thank you.
Yeah. Oh, I think I put. Yeah, my bad. I put 1 hour 15 minutes on the syllabus, but that was supposed to be 2 hours. Okay, so final exam is going to be 120 minutes. Um, I am still making the final exam, so I'm currently not quite sure how many total questions I'm going to put on the exam. So I will make that announcement on Thursday. Okay. Any other question, guys? All right. So last week we've looked at the hybrid orbital, and today we're going to learn about different types of bonds. Okay. So Again, this is a review from your Gen Chem 1, and we're going to review about sigma bond and pi bond. Okay, so let's consider sp2 hybridized carbon for an example. Okay, this is sp2 hybridized carbon. After hybridization, carbon would have 3 of the sp2 hybridized orbitals and 1 unhybridized p orbitals. Okay, so these are the hybrid orbitals. Okay, that lays flat trigonal planar, and this is the unhybridized p orbital that did not participate in the hybridization. Okay, has a regular p orbital shape. Okay, so when two sp2 hybridized carbon come close together, okay, what's going to happen is that the orbitals will overlap. Okay, the orbitals will overlap like so. The overlap of 2 of the sp2 orbitals would form sigma bond. Okay, this will form sigma bond. Okay, and the overlap of p orbital here is going to be form pi bond. Okay, this molecule is carbon carbon double bond. Okay, so this bond is from sigma bond, this bond is from pi bond. Because of the lobes on top and bottom, people might think this will form 2 pi bonds, but that's not the case. This will just form a double bond from 1 pi bond and 1 sigma bond, because the top and bottom electron cloud area represent that the electrons in the pi bond can move around, okay, delocalized. So it can be here or here, okay. So these two aligning of these two lobes count as 1 pi bond, okay. Here is a simple way to remember. Here's a simple way to remember uh, what will form sigma bond and what will form pi bond. Okay, so single bond would always consist of 1 sigma bond. Double bond consists of 1 sigma bond, 1 pi bond. Okay, triple bond would consist of 1 sigma bond and 2 pi bond. Okay, so try to keep this in mind. And here is a better diagram. So here's showing a sigma bond and pi bond in sp2 hybridized and sp hybridized carbons orbital diagram. Okay, as you can see, this is what we just observed in the previous slide. sp2 hybridized carbon would have 3 of the sp2 orbitals, 3 of the sp2 hybridized orbitals laying trigonal planar direction. Okay, and 1 of the p orbital in vertical direction. Okay, when 2 carbon atoms come close together, they will have overlap orbitals. sp2 orbitals overlap, forming 1 sigma bond. P orbitals, they overlap, forming 1 pi bond. The result is formation of carbon-carbon double bond. Okay, how about sp2 hybrid orbital and hydrogen bond? This bond is also sigma bond. Okay, only the overlapping of p orbitals would result in pi bonds. Okay, here is the sp hybrid orbitals, sp hybridized carbons. We have 2 of the sp orbitals, 1, 2, 1 and 2. Okay, each carbon has 2 of the sp hybridized orbitals, and then sp hybrid orbitals have 2 of the p orbitals that did not participate in the hybridization. So 2 of the unhybridized p orbitals are here. Here. Okay. 2 of the unhybridized orbitals lay vertically. The other one laying sideways, okay, sticking out of the screen and sticking towards back of the screen. when two of the sp hybridized orbital come close together, okay, they will form there will be orbital overlaps, and this forms sigma bond. Okay, one sigma bond. Okay, two of the p orbitals overlap, forming two pi bonds. One pi bond, one pi bond, one pi bond, and then one pi bond. Okay, so this is sigma bond. This is pi bond. This is pi bond. This is sigma bond, pi bond. All right, so by now you should have clear understanding of what hybridization is, what hybridization a carbon will have when it has single bond, when it has double bond, when it has triple bond. Okay, so um, this carbon, okay, this carbon composed of all single bonds. This carbon is sp3 hybridized. Okay, this carbon, which has one double bond, this carbon is sp2 hybridized. This carbon is sp hybridized. Okay, sp hybridized carbon. All right, so so now that we learned this, um, you should be able to answer questions related to molecular or electron domain geometry of a carbon atom when it has single bond, double bond, triple bond, which will be that those kind of questions will be on final exam. Okay, the tables will be given to you. Okay, this table will be given to you. So now that we have finished reviewing the hybridization of geometry, we finished reviewing all the hybridization, we have looked at the smaller picture. Okay, we have looked at the hybridization of individual carbon atoms. Okay, now we're actually going to talk about organic compounds that contains. We're going to take a look at bigger picture now. Okay, we're actually going to talk about organic compounds that contains carbon and hydrogens. Um, we're going to talk about some actual organic compounds. Okay, so organic compounds that contain only carbon and hydrogen. Carbon and hydrogen are called hydrocarbons. Okay, there are four basic types of hydrocarbons: alkenes, alkynes, and aromatic hydrocarbons. Okay, alkanes are hydrocarbons that compose of all single bonds. So among these, which one will be alkanes? This will be alkanes, right? Composed of all single bonds. Alkenes are hydrocarbons composed of uh, alkenes are hydrocarbons that contain one double bond, more than one double bond. So if it contains double bond, oops, double bond. Okay, so it contains alkenes contain sp2 hybridized carbons. Okay, alkynes contain triple bonds. So alkynes contain sp hybridized carbons. Okay, so alkane, alkene, alkyne. Okay, make sure you able to oops, recognize the names of the hydrocarbons. Okay, aromatic hydrocarbons are hydrocarbons containing double bonds, which have carbon atoms connected in a ring structure. Okay, so contains sp2 hybridized carbons. So aromatic hydrocarbons look something like this. Okay, this portion. Okay, this portion is sigma bond. And then these are pi bonds. Okay, because as I said in the previous slide, pi electrons in pi bonds, they are delocalized. They can move around. They can jump around. So so in generally, aromatic hydrocarbons are sometimes represented this way. Indicates that electrons within pi bonds, they circle around, they move around, continuously move around. Okay, so aromatic hydrocarbons are hydrocarbons contains double bonds. Carbons connected in a ring structure. Okay, it contains sp2 hybridized carbon. This table shows examples of each type of hydrocarbons mentioned in the previous slides. Okay, so for alkene,
Sorry. On the previous slide, do you see where you have that C highlighted?
Mm-hmm.
Is it just an S?
C highlighted.
Yeah, so next to hydrocarbons, there's an equation and it has a C that's highlighted, and under that you wrote SP something, but
Here?
not,
Oh, here?
yeah.
Oh, this is sp hybridized carbon.
So alkanes, single bonds, would be sp3.
Alkanes will contain carbons that have sp3 hybridization.
Okay.
It contains sp3 hybridized carbons. Okay.
Okay. And then the one on the bottom of that would be sp2 and so forth.
This is sp, triple bond carbon. Alkyne will contain sp hybridized carbon.
I'm sorry. I'm just a little confused.
Mm-hmm.
So
double bond carbon, this carbon is sp2 hybridized.
okay.
Okay, and then triple bond carbon, this carbon is sp hybridized.
So if it's single bonds, it's sp3.
sp3 hybridized carbon, yes.
Okay, I see now. Thank you.
Uh-huh. All right, so here's alkane. Example of this is example of alkane. Example. Okay. This is example of alkane. An example of alkane would be a molecule called ethane, which composed of 2 carbons. Okay, since this is an alkane, all of the bonds within the molecule are single bonds. Okay, again, alkanes compose of all single bonds. Okay, here, which one is sp3 hybridized? Which carbon is sp3 hybridized? This carbon and this carbon, they are both sp3 hybridized. Okay. Moving on to this is typo. This is alkene. Okay. An example of alkene is ethene, okay, which contains double bond, right? This also has 2 carbons. This is an alkene. The bond contains double bond, and the carbons are sp2 hybridized. So which carbons are sp2 hybridized? This carbon and this carbon, they are sp2 hybridized. Okay. Do you guys see here? It looks like carbon is connected to hydrogen, right? But that's incorrect. Carbon is actually connected to carbon. Okay. So a more precise way will be like this. Okay. But this is fine too. But you just have to know that carbon is not double bonded with hydrogens. Okay. Alkynes or hydrocarbons contain triple bonds. Okay, an example of alkyne would be a molecule called ethine. Okay, which also has 2 carbons. These 2 carbons are connected by triple bonds. This carbon is sp hybridized. Okay, let me write that down. This is sp3 hybridized carbon. This is sp2 hybridized carbon. This is sp hybridized carbon. Okay. Aromatic hydrocarbons are hydrocarbons containing double bonds, which have carbon atoms connected to a ring structure. Okay, ring structure. An example of aromatic hydrocarbon is a molecule called benzene, okay, which has 6 carbons linked, joined together in a ring structure. Okay, these carbons, okay, these carbons within aromatic ring, within benzene ring, these are sp2 hybridized carbon. Okay, as you can see, the circle indicates that the pi electrons in the pi bonds are freely moving around. Okay, so in this slide, you don't have to know the example. You don't have to memorize the example. But on the exam, if you're given the structure, you should be able to recognize that it's alkane. If you see a double bond, you should be able to recognize that it's alkene. If you see triple bond, you should be able to identify that it's alkyne. If you see a ring structure with double bond, you should be able to identify that it's aromatic ring. So it can be drawn like this or like this. Okay, they're the same thing.
Professor.
Uh-huh.
So if it's an aromatic, it's always going to be sp2.
sp2. All these carbons are sp2 hybridized.
Okay.
Okay.
Thank you.
All right, so here are some common properties of hydrocarbons. Okay, hydrocarbons are nonpolar. They are insoluble in water. Why? Because if hydrocarbons are nonpolar, water is polar, they will repel, right? So they are insoluble in water, but they are soluble in nonpolar solvents. So like the tricks like, so nonpolar hydrocarbon will be soluble in nonpolar solvents. Okay, melting point and boiling points are determined by dispersion forces, which means hydrocarbons with lower molar mass will be in gaseous state. Hydrocarbons with moderate molar mass will be in liquid state. Hydrocarbons with high molar mass will be in solid state. Here's some of these examples of straight chain alkane series that you don't have to memorize. Okay, methane. Methane is simply hydrocarbon with one carbon. Okay, one carbon. Ethane is hydrocarbon with 2 carbons. Okay, connected together. Propane is 3 carbons connected together. Butane is 3 carbons together. Okay, so carbon, carbon. Oops. Carbon. Looks like this, and for this it looks like this. Okay, all right, this is too messy. The bottom line is that carbons and carbons connect to each other. Okay, not carbon and hydrogen over here. Okay, carbon and carbon connect to each other. All right, so on and so forth. So the pentane will have 5 carbons connected to each other. As you can see, that compounds with low molecular weight, you have less carbon here, so you have low molecular weight in these series, right? So compounds that with low molecular weight has extremely low boiling point. Methane to butane, okay? These contains less carbon, so it will have less molecular weight, right? So these molecule, methane to butane, boils at negative temperature. This tells us that these molecules exist in gas state. They have extremely low, they are boiling even below 0 degrees Celsius. That means they naturally exist in gaseous state. As you can see, as the number of carbon increases, as the number of carbon in the molecular formula increases, the molecular weight of the molecule would also increase, and therefore, as you can see, the pattern that the boiling point is increasing as well. decane, which contains 10 carbons, have the highest boiling point among all. Okay, so you don't have to memorize this table given the you don't have to memorize this table, but if this table is given on the final exam, you should be able to, and if you were asked which one will be in gas state, which one would have highest boiling point, you should be able to analyze this table. Okay, so no need for memorization, but you should be able to. Let me write that down.
Professor, I have a question.
Mm-hmm.
How would we know which one, like where it goes from the liquid to the solid state? Is it like at like above 98, or how would we know based on that chart?
So anything, if it doesn't boil above, if the boiling point is above 0 degrees Celsius, it will be in liquid state. So these are all liquids.
Okay, so none of them are solid?
No.
Okay, thank you.
Mm-hmm.
Dr. Lee,
Mm-hmm.
these are all fuels, right? Are they?
Here. Okay. Here. So here are some practical uses of some of the simple alkanes. Methane, using natural gas, propane, bottle gas, butane, lighter fuel, and then alkanes with 5 to 12 carbon chain. 5 to 12 carbon chain, they are gasoline. Okay, so yeah, good question, but answered in the next slide. Okay, so this one, you don't have to know this for final exam. All right. Here's some methods for writing formulas in organic chemistry. Structure formulas like this do show how atoms are bonded to each other, but this will be rarely used in actual organic chemistry. The more common formulas that is used is the condensed formula or bond line structure, okay, where carbons are represented by lines. So this is the condensed structure, okay, or this, okay. And again, don't misunderstand that this carbon is connected to this hydrogen. Okay, this condensed structure basically tells us that all the carbons are connected to each other. So carbon, 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 carbons are connected, and then hydrogen. Okay, so this is the condensed structure formula. Okay, or you can draw a bond line structure. Okay, so bond line structure, carbons are represented by lines. So you have 1, 2, 3, 4 carbons. So you draw 1, 2. Okay, so you will draw 3 lines. So each location over here represents 1 carbon. Carbon, carbon, carbon. Okay, so you will just draw like this, and you should be able to identify that this is alkane with contains 4 carbon atoms. 1, 2, 3, 4. Okay, this is a bond line structure. So in the bond line structure, any other atoms besides carbons should be written out. Okay, so let's say you want to draw a bond line structure of. Let's say you want to draw a bond line structure of butanol. Okay, 1, 2, 3, 4. Okay, this contains 1, 2, 3, 4 carbons and OH group. This OH group should be written out. Only the carbons should be drawn as lines. Okay, so this is going to be the bond line structure. And in the next couple of slides, we will take a deeper look at alkanes, alkenes, and alkynes. Okay, let's take a look at alkanes first. So alkanes are made up of carbons that are sp3 hybridized, right? So the carbons in alkanes have tetrahedral molecular geometry, okay? Tetrahedral molecular geometry with 109.5 degree bond angles. You don't have to memorize the bond angles. Okay, you don't have to memorize the bond angles, but you need to know the hybridization of carbons in alkanes. Okay, sp3 hybridized. So sp3 hybridized carbons can make 4 bonds. Okay, these are sp3 hybridized orbitals. They can make 4 bonds. These carbons can be linked in a straight chain, or they can be branched as well. So, for example, if you have 1, 2, 3, 4, 1, 2, 3, 4, butane as a chemical formula of C4H10. This formula can be drawn as a straight chain or it can be branched. This is regular butane. This is isobutane. Also has chemical formula of C4H10. These two are called structure isomers.
Professor, I have a question.
Mm-hmm.
How do we know how many hydrogens are going to be there, or is it just something that we have to know and memorize?
So carbon needs 4 bonds, right? So if one carbon is used one bond to bond with other carbon, how many sp3 orbitals are left over?
Sorry, can you repeat that again, please?
Yeah. So carbon, this sp3 hybridized carbon, how many bonds can sp3 hybridized carbon make?
4.
4, right? So if this carbon is using one bond to bond with other carbon, let's say it's using this orbital to bond with other carbon, how many other orbitals are available for bonding with hydrogens?
3.
3. So how many hydrogens do you need?
3 for that
3,
bond.
right? Yeah. So do you get it? So it's
Oh
about
yeah, it makes sense. Okay,
how many?
and then you do that for all 4 carbons, correct?
4 carbons, correct? Yeah.
Okay, that makes sense. Thank you.
So to answer that question, so here this carbon is bonding with this carbon, so you will have 1, 2, 3 hydrogens here. Okay, this carbon is bonding with this carbon, so it has 1, 2, 3 hydrogens over here. 1, 2, 3 hydrogens over here. This carbon is sp3 hybridized. It's bonding with 3 of the carbons. So how many orbitals left over for bonding with hydrogen? 1, right? So this carbon will have 1 hydrogen. Okay. So we're not going to go too deep into the structure isomers. I'm just introducing. You don't have to know this for the final exam. Okay. Don't need to know. Oops. Don't need to know for the final exam here. Okay, so structure isomers don't need to know for the final exam. Cycloalkanes are basically alkanes that form rings or cyclized, or no, it's a cyclized alkanes. So what you have to know from this slide is the stability of different cycloalkanes. So if you can make rings with 3 carbons, 1, 2, 3 carbons versus 1, 2, 3, 4, 5 carbons versus 1, 2, 3, 4, 5, 6 carbons. Okay, so this has 6 carbons, 5 carbons, 3 carbons. If you can make rings with 3 carbons versus 5 carbons and 6 carbons, cycloalkanes with 3 carbons would be least stable due to the ring strain. Okay, sp3 hybridization requires 109.5 degree angles. Okay, so this angle is happily achieved when there are 6-membered rings. Okay, so the most stable cycloalkane would be the one with 6-membered rings. Why? Because if you have 6-member ring, the nice close to 109.5-degree angle is achieved. Okay, so the stability goes from the most stable when you have 6-carbon member ring, and then the stability drops down when you have 5-carbon member ring. Okay, and then when you have 3-carbon member ring, this can exist. However, it's going to be very, very unstable. It will very easily participate in a reaction, just break the bond and create something else. Okay, so from here, from this slide, for final exam, know the stability of different cycloalkanes. Okay. All right. So here, all you need to know is that alkanes are relatively unreactive. Okay. Alkanes are relatively unreactive due to lack of polarity. Okay. And then they are made up of sigma bonds. Sigma bonds, which are very stable. Sigma bond is a pretty stable bond. If you are bonded with a stable bond, it will rarely undergo changes. Okay, they will rarely participate in the chemical reactions. Okay, so just know that alkenes are relatively unreactive due to the lack of polarity and presence of stable sigma bond. Okay, due to the two factors. All right, so alkanes with single bonds only are called saturated hydrocarbons. Okay, alkanes with single bonds only are called saturated hydrocarbons, and alkanes with double bonds, okay, double bonds, triple bonds, and aromatic hydrocarbons with double bonds, these will have less hydrogen in the molecular formula, and therefore these are referred to as unsaturated hydrocarbons. Okay, so as in general, unsaturated hydrocarbons are more reactive than saturated hydrocarbons. Okay, so alkane, saturated hydrocarbons, alkene, alkyne, aromatic hydrocarbon, these are unsaturated. Okay, these are max saturated with hydrogens. These have less hydrogen, so it's unsaturated hydrocarbons. Okay, so alkenes are hydrocarbons that contain at least one carbon-carbon double bond. Okay, again, one of the double bond is going to be sigma bond, other bond is going to be pi bond, right? Here, you don't have to know this information. The only thing you need to know is that alkanes are connected by carbon-carbon double bond, okay, composed of one sigma bond and one pi bond. Alkynes are hydrocarbons that contain at least one carbon-carbon triple bond. Again, within triple bond, one of the bond is going to be sigma bond. The other two is going to be pi bond, right? Again, these are unsaturated. The naming you don't have to know. Okay. And aromatic hydrocarbons are hydrocarbons with 6-member ring with localized and delocalized electrons. Okay, so the sigma bond these are pi bonds. Okay, so electrons in the sigma bond, they are localized. They don't move around. They're there. Okay? They're locked. Electrons in the pi bonds, they are delocalized. They move around. Okay?
Dr. Lee?
Yes?
So we won't need to know how to name alkenes, alkanes, and alkynes for the final. Like,
No.
I know in the homework they gave like
Mm-hmm.
a chain, and then they said to name the alkane. Will questions like that be asked?
For final exam, no.
Okay. Okay. Thank you.
Wait, there's a naming in the homework?
There's a lot. That's why I remember last class you said that you were going to do orbital questioning, like questioning on the orbital and hybridization. There was no there was no questions like that on the homework. There was
Oh yeah, of course. That's because that's a review from Gen Chem 1.
and mostly it was naming of alkanes and knowing how many hydrogens are going to be in like certain chains and stuff like that.
Let me see where the naming is, because I thought I removed everything that's unnecessary. Okay, molecular formula contains aromatic ring. Oh, okay. Naming of the functional group, yeah, we will go over that in a little bit. Okay, but the specific name you don't have to know. For this, you don't have to know for now, but for naming of the function, you have to be able to identify the functional group. So we're gonna cover that coming up soon. Okay, so yeah, hang on a little bit.
Sorry.
Yeah, okay. So and then this rest. Yeah, I wanted to cover as much as I can, but I realized that we're running out of time, and I really want to cover uh, whatever is very, very important for those students who are going to take organic chemistry in the next semester. Okay, so I'm going fast paced, but whatever I'm covering right now is going to be very important concepts for coming up organic chemistry. These naming, they are pretty easy. The key characteristics, features, these will cover, you will learn this in organic chemistry in further detail. Okay, I'm just giving you a brief overview, introduction of different organic chemistry molecules and different functional groups. Okay, so here are some examples of aromatic hydrocarbons. Okay, this is the aromatic hydrocarbon, benzene, right? These are aromatic hydrocarbon benzene undergoing various chemical reactions. Do you have to know this? You don't have to know this. Okay, you don't have to know this for a final exam. I'm showing you this because a question related to nitrobenzene is on your homework assignment. I didn't want you to guys be surprised. Okay, so nitrobenzene is going to look something like this. It's a reaction between benzene and nitric acid with the using sulfuric acid as a catalyst. You will form nitrobenzene molecule. Okay, so if you see it on your homework, don't be surprised. Okay, again, you don't have to know this for the final exam. Now that we've explored enough of hydrocarbons, we will take a look at various types of functional groups in organic chemistry. Okay, so in organic chemistry, if it's written as ROH, this this portion is referred to as alkyl or hydrocarbon. Anything that contains carbon and hydrogen only. Okay, and this OH portion, this is called functional group. Okay, functional groups are groups that give characteristics for an organic compound. So for example, this molecule ROH contains OH functional group, right? So because it has OH group, this molecule is an alcohol. Okay, so this is a functional group, and the R indicates hydrocarbon. Okay, so here are various types of functional groups. This is the table that you want to memorize. memorize first two columns. Table 24.6. Okay. You don't have to be scared. You don't have to draw anything on the final exam. But what the final exam is going to ask is, if you are given a structure, you should be able to determine the compound type or functional group, vice versa. Okay, all you have to focus is these first two columns. Okay, so if you see a carbon and carbon linked by double bond, that compound type is alkene. Okay, if you have carbon linked by triple bond, that compound type is alkyne. Carbon linked with carbon with single bond, that's alkane, right? Okay, if you have this functional group is alcohol. Okay. This functional group is alcohol. If you see OH in the structural formula, this is alcohol. Again, this hydrocarbon portion can be written as R. OH. Okay. This is the alcohol. This is the functional group alcohol. Okay. Moving on to next part of the table. Again, you have to memorize this. If you see oxygen sandwiched between carbons, okay, that functional group is called ether. Okay, so this can also be written as ROR. Okay, hydrocarbon, oxygen, hydrocarbon, hydrocarbon, oxygen, hydrocarbon. This entire thing is called ether. If you have hydrocarbon linked to oxygen and linked to other side of the oxygen linked to another hydrocarbon, that functional group is called ether. Okay. When you have halogen, okay, group 7A element connected to hydrocarbon, okay, this can also be written as RX, right? Okay, this functional group is called alkyl halide. You don't have to know this, haloalkane. Okay, it's called alkyl halide. And you don't have to know this. We're not going to focus anything that contains nitrogen. Okay. For next part of the table 24.6, we have aldehyde. So anything that has this functional group is called aldehyde. Anything that has this functional group is called ketone. Anything that has this functional group is called carboxylic acid. Okay. Anything that has this functional group is called ester. This one is we're going to skip. Okay, so in next few slides, we're going to take a deeper look at aldehyde, ketone, carboxylic acid, and ester. Okay, we're going to take a deeper look at ether and alcohol as well too. Okay, first of all, alcohol. Okay, alcohol. Here are some examples of organic molecules with OH functional group. Okay. You don't have to know this for the final exam, so don't be scared. Okay. OH group, as you can see, all of these organic molecules contains OH, 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 OH. Okay, so this functional group is called alcohol, or this specific OH group is called hydroxyl group. Okay, so to be more accurate, we say if a molecule contains hydroxyl group, that molecule is considered alcohol. Okay, so this is a hydroxyl functional group. If a molecule contains hydroxyl group, that molecule is considered as an alcohol. Okay. Again, we don't have to know the specific naming of the alcohol. Okay. So the only part that you have to focus is that alcohol contains hydroxyl group. Okay. Here are some of the properties and uses of alcohols. OH group, the hydroxyl group, is a polar group. Okay, it's a polar functional group which makes organic compounds contain hydroxyl group polar. Okay, so because hydroxyl group is polar, molecule contain OH is polar. Okay, so therefore most alcohols are pretty soluble in water. Okay, and you should cross out higher boiling point. Some of the alcohols have low boiling point. Okay, so why is it soluble in water? Because of this polar hydroxyl group. Okay, like attracts like. Below are some practical usage of alcohols in daily life. Okay, ethanol in alcoholic beverages, ethylene glycol, antifreeze, glycerol, phenols, so on and so forth. Try to read through, but these won't be on the final exam. Okay. Don't need to know for final exam. Okay. But try to read through. Pretty fun. All right, moving on to ethers. Ethers are organic functional group that has oxygen sandwiched between carbons. Okay, as you can see, oxygen sandwiched between carbons. Those R's are carbons, hydrocarbons. Okay, so below are some of the examples of compounds with ether functional group. Okay, here it looks like oxygen is connected to hydrogen, right? But that's not the case. Oxygen is connected to carbon. Okay. Okay, so oxygen is connected to carbon, carbon. Okay, as you can see, oxygen is connected to carbon, connected to carbon. Okay, oxygen sandwiched between carbons. Okay, those are called ethers. Okay, so if you are given various structures of organic molecule, you should be able to identify which one is ethers on your final exam. Okay. When you take organic chemistry in the future, you will use this solvent a lot in the organic chemistry lab. So that's that. And next up, we're going to look at the functional groups that contains carbonyl group. Well, so what is carbonyl group? Carbonyl group is when carbon is connected to oxygen via double bond. This group is called carbonyl group. Okay. Carbonyl. And any functional group, and below are the functional groups that contains these carbonyl groups. So aldehydes, ketones, carboxylic acids, esters, we're not going to do the amides, okay? So these ones that you saw in table 24.9 earlier, 24.6 earlier here, ester, carboxylic acid, ketone, aldehyde, they all contain this carbonyl group, C double bond O. Okay. They all contain this carbonyl group. So let's take a look at aldehydes and ketones first. Okay. Aldehydes have carbonyl group. Okay. And then, very importantly, carbonyl group and one hydrogen attached to carbonyl carbon. Okay, not any carbon. It has to be attached to the carbonyl carbon. Okay, so write that down. Aldehyde has one hydrogen attached to carbonyl carbon. Not any carbon, just carbonyl carbon. Okay. Ketones. Let's take a look at ketones. Ketones have carbonyl carbons. Okay. Ketones have carbons attached to both sides of carbonyl carbon. Ketones have carbons attached to both sides of the carbonyl carbon. Okay. Again, this carbon is linked to carbon, not hydrogen. Okay. Okay, let's write that down. Ketones have carbons attached to both sides of carbonyl carbon. Okay, so those are the difference between aldehyde and ketone. Pretty easy to recognize, right? If anyone's confused, let me know, please. Here are some practical usage of aldehydes and ketones. Try to read through these, but these won't be on the final exam. Okay. Moving on to carboxylic acid. Carboxylic acid are also, carboxylic acid is a functional group, also contains carbonyl group. Okay. You don't have to know these features. Okay. You just have to know the hydroxyl group bonded to the carbonyl group. Let's take a look at the structure. Here are some of the examples of carboxylic acids. Okay. Carboxylic acid have these carbonyl group. Okay. And then what? And then you have hydroxyl group attached to the carbonyl carbon. Hydroxyl group attached to the carbonyl carbon. Okay, so let's make a note. So carboxylic acid has hydroxyl group, OH group attached to the carbonyl carbon. Okay. Moving on to ester. Ester also have carbonyl groups. Okay. Esters have one side of oxygen connected to carbonyl carbon, and then the other side is connected to hydrocarbon. Okay. So again, esters have this carbonyl group. Okay. One side of the oxygen connected to carbonyl carbon, and then the other side is connected to a hydrocarbon. Let's simplify this. So ester will have general formula of R, O connected to different R group. Okay, this is a carbonyl group. One side of the oxygen is connected to the carbonyl carbon. The other side of the oxygen is connected to other hydrocarbon. Okay, this is the ester functional group. Let me write that down. Okay, one side of oxygen connected to carbonyl carbon and other side connected to other connected to hydrocarbon, denoted as R prime in this diagram over here. Okay. Again, you don't have to know this, you don't have to know the naming. Okay. And then we're not going to cover anything with nitrogen. All right, so that is the end of chapter 24. That was the last lecture of Gen Chem 2. Let me quickly quickly go over what will be on the final exam for this chapter 24. Okay, so take a note. All right, so here's what's going to be on the final exam for this chapter. Valence bond theory. Make sure you know how to identify hybridizations of carbon. You don't have to focus on other atoms, okay? You just have to know the hybridization of carbons, okay? So here, I showed you the examples with beryllium, beryllium and boron over here, right? But these are, I was just showing this so that it's easier for you to understand. What you only have to focus is the hybridization of the carbons, okay? So review the hybridization of carbons, okay? Make sure you know the difference between sigma bond and pi bond that we learned today. Difference between sigma bond and pi bond, okay? Make sure you can differentiate between hydrocarbons, alkane versus alkene versus alkyne, okay? Between saturated and unsaturated hydrocarbons. Make sure you memorize first two columns of the table. First two columns of this table, 24.6, okay? If the structure is given to you, you should be able to come up with the functional group name. You should be able to identify the correct functional group name. If the functional group name is given, you should be able to identify the appropriate structure. Okay, so if the question asks, find a functional group, find a compound that contains aldehyde among these molecules, then you should be able to identify the correct molecules that contains the aldehyde functional group. Okay, so yep, those four. Review the valence bond theory. Make sure you know how to identify the hybridization of carbons. Number 2, make sure you know the difference between sigma bond and pi bond. Number 3, make sure you can differentiate between hydrocarbons and alkenes or alkyne. Number 4, make sure you memorize the first two columns of table 24.6. Okay, those 4 things. Any other question, guys? All right, so if there's no other question, I have to go somewhere, so I can't stay longer. If you have any questions, send me an email. Again, the final exam topic sheet is going to be uploaded sometime tonight, maybe tomorrow morning if I can't finish by today, okay? But I'll try to upload as soon as possible. In the meantime, try to review the chapter 24 and finish up the homework, okay? If you need more time for the homework, please let me know, okay? I can definitely extend the time, the due date for the homework, but I feel like if you complete your homework before the final exam is going to help you a lot. But if you need more time for the homework, then let me know. I can definitely extend the deadline for the homework to maybe May 11th. Okay, so that's that. And please attend Thursday's final exam review session. I will give out a lot of tips regarding how to prepare for the final exam, what potential questions are going to be on the exam, etc. Okay, so if you don't have any questions, I'm going to end the meeting here. Okay, and I'll